Now I need you to draw 4 little boxes in the corners of each of these one node. The top left and right represents the earlies or the early start and the early finish. The bottom corners represent the late finish and the early finish of the project. And so lay it out accordingly. And after you lay it out, what I need you to do next is to go ahead and enter the values from the start, determining the earliest time the task can begin and finish. So basically, from the start, 0 days have elapsed, and we will see that in the case of A, it needs 5 days worth of duration. 5 then goes into the upper right, which is the early finish. The earliest it will finish is 5 days. 0 is its early start because it has no predecessors, right? Now, look at C. C can only begin after A is finished. Therefore, the earliest start is 5 days. Add 4 days, which is our estimate of C, and we will get 9. Moving on to F, we take 9, transpose it over as the early start of F, plus 4, and we get 13. We have to pause here because to go to I, we have dependencies with G and H. So following the same instructions, we do the same thing with B, with D, with G, and the rest with E, H, and J. So in the case of B, it's 4 days duration. It transposes as an early start for D. 4 plus 4 is 8. And 8 transposes to G. G plus 8 plus 5 equals 13. And we pause. And we continue the other paths. And each one of those lines, connected lines, is a path in the critical path. And that's what we will get. If we do this, we look at the rule. The rule is, when it comes to the early starts, is when 2 or more arrows enter a task, the early start is the largest of the preceding task's early finish. Makes sense, right? You can't start until the last predecessor is finished doing what it's supposed to do. So in this case, in this example we gave, we look at F, which is 13 days. The G path is 13 days. The H path is 15 days. Therefore, 15 becomes the early start of I. 15 plus 8 is 23. 23 goes to the end node. That means that the earliest, or the forward pass, the earliest that we can finish this project is 23 days. All right. Once you're finished with the forward pass, we now look at the backward pass. The backward pass is sometimes called the late schedule and reveals for us the critical path. So starting with the end node, now we're working with the 2 lower corners, and we're going from end to start. We're going backwards here, right? So we take the value of end, which is 23, and becomes the late finish of number 8. 23 minus 8, you will have to subtract, becomes the late start, which is 15. So 23 minus 8 is 15. We pause, right, because of the predecessors, and 15 will go in the lower corners of F, G, and H. Yeah? In the case of J, because it has no dependency with the others, 23 goes right down there, minus 8, 15, and then it backs in. And you follow the logic, and you will see the numbers unfold in front of you. When 2 or more arrows back into a task, the late finish is the smallest of the succeeding task's late start. Makes sense, right? Late start, therefore, is the least of the succeeding task. When we finish this example, the critical path will show to be B, path. That's the critical path. Any delay along that path would mean a delay in the entire project. Sometimes people call this the PERT CPM, Program Evaluation Review Technique, Critical Path Methodology. That's a very engineering or a very MBA related in production discipline, production planning discipline, but this is applied also in project management. In as far as the float and the slack of other paths, you will see that the A, C, F, they have a float, they have a slack, meaning any one of those tasks can be delayed to a certain number of days. It looks like a couple of days before it will have impact to the project. So you, as a project manager, you focus on the critical path and secondarily on the near critical path. Let's go into an example.